Alright, so here's a half-life question about some plutonium that's got a half-life of 88 years. And the way we write that in notation is T sub 1/2 equals 88 years. Okay, and we want to find out what the annual rate of decay is. And in the formula, that's lambda. Formula was n of t equals n sub naught e to the negative lambda times time. So it's negative because it's got to be a decay model. Lambda is actually a positive rate. It's a positive number. If you don't remember that formula, no big deal. You can always use the PERT formula. Gives you the same thing, except for here, there's no negative. At the very, very end, when we solve it, we'll get a negative rate. And just keep in mind that the actual decay rate is positive. Okay, so if I were going to solve this for the actual rate, I need to come up with an original amount, let's say 2, and then after we're all done, we'll get 1, like gram or pound, I don't know, whatever, e to the negative lambda times our time, and our time frame is 88, and we're going to solve this for lambda. So divide by 2, 1/2 equals e negative 88 lambda, and take the natural log both sides. Natural log of 1/2 equals, and then it'll cancel out over here, just giving me negative 88 lambda, and then after I divide, my lambda is equal to the natural log of 1/2 divided by negative 88. So there would be the exact value of lambda. If we had used the PERT model, we would have gotten the same exact thing, except for it would have been natural log of 1/2 over just 88. This one over here is positive. This one will be negative, and like I said, you just have to keep in mind that the actual lambda is a positive number. Now, in class, we talked about the formula. If we already knew what the half-life is, we can go straight to lambda. We derive this as the natural log of 2 divided by half-life, which is just 88. So let me plug that into the calculator here. Natural log of 2, close those parentheses, divided by 88. And we get about 0.00788. About 0.00788. And now whenever I use this in some calculations, I don't want to have all of those rounded decimals. So if I go back to the calculator, we can just store this as, how about A. So now every time I need to call up that decay rate again, I just put in alpha A, and it's there. All right, stay tuned for parts 5 and 6.